Hey everyone, welcome back to the Engineering Success Podcast, your go-to spot for straight talk and smart strategies for today's software leaders. Our today's guest is a tech veteran with over 20 years of leading engineering teams in the US and Southeast Asia. He is a former engineering lead from PayPal and now leading engineering at Circles. He isn't just a boss, he's also a writer who talks about building tech that scales. He's seen it all, from the early startup days to major exits, and now he's here to share that wealth of knowledge with us today. He is going to talk about making engineering workflows better and why strong foundations matter for scaling tech startups. Whether you're just starting out or running a growing team, you'll find something useful here.
My name is Himanshu. I started this engineering success podcast a little over, I guess it's been about 4 months. Just finished with the first season of it. I'm speaking to engineering leaders on different themes. Sometimes it used to be the use of AI in management, or what were the team management principles, or things that work for them. And I figured out that there's this one specific area where there's sort of an unset traction towards it. People want to talk about it, but there's no structured discussion happening around that. It's resource allocation. Like when you're working with a limited capital, and now more so because it's the whole era of layoffs, I guess. Every day, if you open a newspaper or if you're online, you will see that somebody somewhere is laying off. So that means we're working with limited resources. And that's both. Like it could be in terms of capital, it could be in terms of uh, your limited team. And then amongst all this, how do you keep your releases on track? How do you plan for or let's say 2 quarters ahead? I think in this conversation, we'll dive deeper into it with you.
Thank you very much for having me. So I think it's a very important topic, especially in terms of starting up a business and especially in startups, scaling and capital resource allocation, how to prioritize, what to prioritize. And this is a subject that's not talked about a lot, but actually a lot of CTOs, engineering leaders struggle to find a formula that works. So basically, I started back in early days in my schooling. I got hooked onto computers and really wanted to learn, and that was my fascination and obsession at that time. And in the late 90s, I built while I was in school, had a small setup where I was building websites for companies, then start my career in the US, going to a startup. So startup world taught me a lot in terms of, hey, like I've seen from zero, from greenfield. I've been the only guy on the technology side, building the whole team up to exit, plus also coming in to a startup where you are inheriting all the decisions that your predecessors have made, and really assess the situation and really put the company on a track to scale. So been doing this for about 2 decades, and I was really extremely lucky to be a part of some great teams, had great mentors. And also some of these things that I've learned are based on the people who have written extensively about this, like Silicon Valley Product Group, Eric Evans, and Martin Fowler. So all these great leaders who have thought through some of these problems. So simply what I've done is really being able to put this into practice, and obviously done my fair share of mistakes, hard learnings. And so I started my career in the 2000s, late 90s, 2000s, and did a couple of successful startups. One of the startups got bought by PayPal. I was in PayPal, and that's how I got into Venmo. Venmo had some scaling challenges. Obviously, the user base was growing significantly. And how do we now scale, and how do we set up the foundation to scale? And then after 2 decades in the US, wanted to see how to build this in Asia. So be a part of the startup ecosystem in Asia, and coming to Asia was a big part of my decision to relocate to Singapore in 2019. So into the telco space, and telco, similar to fintech, is a highly regulated. Nobody has disrupted the space. So I joined Circles, where I lead product and technology, to really help build up a global company from Singapore. So that was a unique experience. So everything I've learned, and also putting into practice in Circles, but also I learned a lot more in terms of how do you really build an organization foundation for scaling. You have limited capital, when you have limited access to talent, when you're in a completely different geographic setting, right? So it really tested the formulas and strategies that I had to put in place for the last 5 years. So that's my journey so far, and really lucky to be a part of that extreme growth curve during the last 2 decades, and especially last 5 years.
It's been quite a journey. How different is the whole startup ecosystem in US versus, in your experience, what you saw in Southeast Asia, in Singapore specifically? Apart from the capital and resources, as you said, like, are there any other differences that you see?
No, I think there are stark differences. Like the startup culture is not as prevalent in this part of the world, like in the US, right? Everybody talks about, hey, how Apple started in a garage, how Amazon started, and it's part of the culture. And people who join startups know what to expect, and certain type of people join startups. But in Southeast Asia, there have not been a lot of great stories, and people have not seen a lot of great success stories coming out of Southeast Asia and becoming global companies. So the people who join startups were a little skeptical. And the best, I don't think they join startups in Southeast Asia. They go to big MNC companies. So there's a lack of talent uh, to tap into. So that's the biggest challenge. Also because Southeast Asia has not seen like big tech companies come out at scale. So people have not seen scale. The potential is there, raw potential is there in talent, but they have not seen or experienced scale. So those are the few challenges.
I think there's a lot of cultural context to it as well. Like in Southeast Asia and in Asian countries, when you grow up, our parents and generations before us are coming from a certain background of not having enough. And then the next generation is focused on just let me build that stability for me and my family. I think that's the general, which is totally in contrast to what we see in the US.
Yeah, the risk tolerance for risk is very low, right? Obviously, in startups, right, the majority of startups fail during the first few years of it, and only a few get to scale, and even few startups get to exit, right? So the failure rate is extremely high, uncertainty is extremely high. People like to have stability, people like to work for big brand companies, and it's a pride of the family in terms of, hey, my son is working at Apple or my daughter is working at Facebook. But that doesn't mean that they are doing the most exciting work and they're living up to their full potential, but it gives them the stability that they need. And this is a big factor to draw talent. Like if you look at the topmost talent coming out of universities, their first preference is not go start a startup or join a startup. Their preference is to get into a big logo company so that they have the stability and they can really fit into the cultural norms and be a part of that community. So this actually hinders the startup ecosystem.
You spent a lot of time working with startups. So what was your motivation to get into? Like, were you always this kind of a risk taker?
Yeah, I think the main thing is startup are like playing intellectual sports, right? So basically, it's joining a group of people who wants to build something great and wants to dream big and really put in the hard work to do it, right? So it's really a fulfilling journey for me. That so the whole part of the startup journey is the most important thing. Like the people who you work with and being able to play these intellectual sports, solving problems and building lasting bonds, friendships along the way, and really looking back, trying to solve some tough problems. And once if you're lucky to get the right team in place and you solve those problems, and you'll have a successful exit. And when you look back, it's one of the most important achievements that you've done in your life, right? Something productive. You created business, you created value, and you really maximize shareholder value. So I always wanted to be in that journey where I am producing something for the greater good of society, or we can say for people who are working, solving complex problems, challenges.
Yeah. So for starters, I think I'm going to keep this quote. Startup is an intellectual sport.
Yeah, it's really that. So a group of people,
Yeah.
why would like the people you work with is much more important when you're doing a startup, right? So you want to have people who are like-minded, who have the same goals in life, who are also different in thinking, but who will really dream big, take some risks, solve some challenging problems, not afraid to work hard, and really enjoy the journey of that whole process, right? So really, startups is like a intellectual team sport that you play with like joining a football club or something like that in a different world and try to win the World Cup.
This reminds me of a conversation which I had recently with, on one of our episodes, we had one of the co-founders of Joomla, Mitch Pittle, and Mitch said that engineering is a team sport rather than focusing on one 10x engineer or getting one brilliant engineer. The entire team has to be 10x because you can't write the whole business or can't write the whole engineering on just one person's back. So how do you look at this whole next engineer versus 10x team kind of debate? Because I do hear a lot of people talking about getting, hiring
Yeah,
10x engineers.
yeah, I think so. Most importantly, right? So now with AI coming into the big picture, right now everyone can code, including ChatGPT, right? So like knowing a language or knowing a technology is not a big competitive advantage for an engineer. So when I look at 10x engineers always in startups are the people who really learn the domain, learn the business, really getting closer to customers, really understanding the problems we need to solve, and really bringing the technology to solve that. So a lot of the time, I think last 2 decades, I've seen this big shift. People who are focusing more on technologies like, hey, I know Java, I know Python, I know Ruby on Rails, right? But people who are not solving problems. So the 10x engineer for me is someone who's deeply immersed in the business, who understands the domain, who will then really apply the intellectual knowledge they have and the technology expertise they have to solve those problems in a meaningful way that customers love and works for the business. So those people are very hard to find, and it all depends on the culture. So what sort of culture you want to set up, right? So a lot of the time, I find that when startups are scaling, they start off with small teams, but then when you scale, that culture disappears and you become a feature factory, right? Everybody wants to ship features faster and faster. They don't really, engineers are far removed from, hey, what problem am I solving, right? Whether customers are using my feature, right? Am I really adding value? So they get far removed from it. So that's where the problem starts.
I think that's an interesting perspective. A 10x engineer is somebody who's going beyond the traditional boundaries of being an engineer and you engaging with the product team and then looking at how consumers are interacting with your product, being more business aware. This just brings me to this question that these days with this whole notion of remote work, people working in distributed teams. So first of all, engineers never really had that context of business. You're not taught that in your college or even in your early days when you're working on certain projects. So it's essentially a ticket is assigned to you, you work on it and your work is done. So you were never really into that whole business discussion in the first place. And now with distributed teams, to me, it looks as if it's becoming more difficult to really get engineers to be more business aware with the whole remote work.
No, yeah, so I think there's a pros and cons, right? So let's talk about like why earlier, like past 2 decades, right? The incentives were very different. Even colleges were producing IT graduates who knows how to write programs, not necessarily business aware. And because the world went through commoditization of engineering. Like when I started the engineering in 80s and 90s, there were not so many different types of engineers. Now you have, like, for example, you have like in the engineering hierarchy, you have specialization like QA, performance scale. You have senior engineers, junior engineers, architects. So there's so many thousands of designations that go around, and this commoditization really helped offshoring. So offshoring, the demand was so much, the supply, university started producing a lot of graduates who knows Python, who knows coding, who knows the basic stuff, but they didn't really talk about the business acumen for engineers. But now the big shift is happening with now generative AI coming in. The generative AI, as it improves, the models improve, they can do some of the basic coding. So knowing a programming language is not the engineer's competitive advantage. Think engineers who are immersed in the business, who understands the products that they're building, customers, and what problems to solve, and leveraging technology to solve them are much more valuable than commodity engineers.
Mm.
So this shift is happening as we speak, subtly.
Mhm.
Companies will value engineers who will take the initiative. If you're in fintech, for example, if you're in cross-border, really understanding the problems, because engineers are the ones who can really talk about the feasibility of a solution, right? The product teams can't do that. Designers can't do that. So the engineering stakeholder has to know the domain, know the business, and really jointly understand what is the impact of the problem that they're solving and how technology can help solve this problem in a much feasible way.
So you spoke about culture being a strong aspect. In terms of culture, what is it that engineering leads or teams could do to empower their own engineers to be more business aware? With your whole more than 2 decades of experience, what could you,
Yeah.
tell us around that?
No, I think so. Typically, if you step back, right, when you're a startup, Series A kind of
Mhm.
startup, you have a small team, you iterate fast, and actually the first set of engineers who join to do that Series A startup uh, funded, they actually know the business a lot more.
Mhm.
Then when you start scaling, the mistake people do is start doubling the teams, hiring more and more people. So instead of spending time really getting them closer to the problem, getting them closer to the customer, getting them closer to the product, we give them list of features, tasks to do,
Mhm.
right? So all of a sudden now you're doubling your capacity, but also you have a roadmap that's given to them to execute. So basically you're creating a culture where people have to just complete the task regardless of the outcome. What startups generally, when they scale, what they realize is when they go to Series B, C, D, what they realize is, hey, we are doing a lot of things, but only 10 to 20% of them actually produce outcomes,
Mhm.
right? So the problem is startups, what they do is when you're in this feature team mode, you ship a lot of features, but the iteration or the feedback loop is not there. The
Yeah.
teams move on to the next feature. So you have a bunch of features, MVPs that you now released, but
Mhm.
not hitting the mark, right? Nobody's iterating. But when you were small, pre-series A, you had a small team, you were laser focused on certain outcomes, you would iterate much more faster to achieve those
Mhm.
outcomes. So this culture when you scale, this culture disappears and you
Yeah.
go into these feature teams. So this is the biggest problem that startups have. How do you keep that culture of and product teams and that same speed of iteration throughout the scaling journey, so that majority of the work you do actually end up being the outcomes that you want to achieve.
Your engineering has to be more aligned with the business objective.
Yeah, so a couple of things, right? So I'll give you in 3 phases. So I put it into 3 phases. Like first phase is, hey, when we are scaling a startup,
Mhm.
uh, how we build software matters.
Mhm.
That means like you have to how do you know when you are bringing on more people, your productivity remains the same or it improves,
Mhm.
right? What do you measure, right? So phase one this is purely in the engineering. It's not product, it's not
Mhm.
anything else. So I call this, you have to measure the flow. Measure the flow is say, what is the lead time to production? Like a developer commits code, how long does it take to go to production,
Mhm.
right? Typically you want to have it in less than 1 day. Then how many times a day are you shipping code to production, right? What is the change failure rate? And when something fails, how fast can you restore them?
Mhm.
Actually gives you a sense of how the flow is working, engineering flow. Like if you look at engineering as a factory, how is the, so these are the basic things that when you measure, you'll see, hey, okay, my lead time to production is really high. I can only ship things to production only once in 2 weeks, right? My sprint finishes in 2 weeks, then only I ship to production. That's not great. Then if you really uncover why that is happening, you'll see that lot of the time we have our architecture is not designed to be loosely coupled. So engineers can't ship code because there's complexity so much, there's spaghetti or so much cyclical dependencies with other services. Or some companies have taken the microservices to the extreme end. You have hundreds of microservices that you have now dependencies that you have to work through to get something out. So getting your architecture loosely coupled with the right granularity is going to be really important. So then other thing is engineers make a mistake is not going into trunk-based development. So typically what happens is engineers have feature branches and they work on the feature, and then ultimately you do a big bang release, then you don't have automation, then all the environments break, and you end up spending hours and days and weeks trying to figure that out. So the entire production line is stopped. And also the version control. People don't version control, including infrastructure, databases, everything. So there are manual steps involved. So this is where the capital efficiency goes away. And automation, CI/CD, completely automating the inner loop, outer loop, and having a great SRE practice. So if these foundational elements are there, your engineering productivity is really good, and you can now scale, still maintaining that level of productivity. Without that, if you add people, you're just burning money, because you have more people you add, more inefficient your system gets. Then what happens is, obviously business has pressure to deliver stuff. Then people go into this feature factory mode and assign feature teams and start developing feature teams, but not fix the root cause of the problem. So the flow is broken, flow is broken from coding to production, and adding people makes it worse. So this is the first fundamental trap that a lot of engineering leaders, tech leads fall into, because the first time, always I need more people is the answer.
Yeah.
Right. So that's what I have seen. A lot of people, including myself, when I started, I made that mistake. So now what I do is I really measure the flow. I like, hey, what are lead time to production? How many deployments per day we shipping to production? Change failure rate, how fast we can recover, what is the gold standard, where we are, why that is happening, and really solve those problems first. So when you solve those problems, once you get to a place where you're shipping code, lead time production less than 1 day, you're shipping multiple releases a day to production, your change failure rate is less than 5%, and time to restore service is less than 30 minutes. Now you know that, hey, now I can add people to this and still maintain these metrics, right? So that is the engineering part. That doesn't necessarily mean you fix the business outcomes problem. So what I'm talking about is, say, engineering, first phase is, say, engineering foundation. Do we have a great foundation? And how we are building software, does it meet the right standard of productivity? So then take you to phase 2, which is how we solve problems, right? So basically what I do is, this is where the tech leads have to play a very important role in partnering with the product managers and designers. So I call it the 3 in a box, where these 3 really have to come together to really align on what problems we are going to solve, how we are going to solve those problems. So like the product discovery, they have to be involved in the product discovery, because product manager talks about, hey, value and viability, designer talks about usability, and engineer, tech lead on the feasibility aspect. So this phase 2 is very important, where we set up these product teams, 3 in a box teams, aligned to problems that are outcome focused, not output focused.
Yeah.
So this is the big shift. The second phase is the big shift towards outcomes. And to do this, phase 1 also has to get right. So because currently where the capital is wasted because people go into this feature factory mode. So
Yeah.
they ship about 100 features, but only 20 of those features actually drive outcomes. That means 80% of the work that you did, you just wasted, right? To focus on outcome. What counts is not the first release, the number of iterations you go through fast to hit that outcome.
Yeah.
Because there's no way that the first release will hit the outcome. If it does, it's fantastic. So the first release is the starting point, and you iterate fast on that by learning, getting insights from the customers, getting insights from the business, what's working, what's not working, and changing until you hit the outcome and solve the problem, right? So that's the mindset change that you require. So that your most precious commodity, that is your engineering capacity, is really working on the most important problems and they are delivering the outcomes.
Yeah, it's built on the foundation of the first phase that you said, that once you get a zoomed out view, once you start measuring those metrics, you get visibility on certain lead times or your MTTR, you're looking at the DORA metrics and whatever other benchmarks that you want to look at. Once you build this, you really get a understanding of the capacity or to what extent can you maximize the current team's output. And once you have this adds to the second layer, I mean, which you just discussed, that now this gives you an ability to really plan better. And this also indicates this, that now the definition of success of an engineer's job has changed. It's no longer about you being able to bring something into production. This is what it used to be. Now it's more about
That's table
how.
stakes. And now it's about how you partner with product and design to solve a problem and deliver an outcome for the business. So the outcome has to be in a way that your customers really love it, but also it's great for the business.
Yeah. So in all of this, I think I would want to move to the second phase of our discussion. Want to deep dive into certain planning aspects and allocation aspects of engineering. How can let's say, considering a scenario of a early stage, maybe a pre-series A, series A level kind of startup, how can one engineering lead go about planning for the next, let's say, 2 to 3 quarters in terms of resources and team allocation? What are the few things that one person should keep in mind when he goes ahead?
Yeah. So I think the series A, B startup, right? You have to, that's where I think the most important work for scaling up should be done.
Mhm.
I think also it's important to balance, hey, some of the business priorities we need to get done and having the right foundation. So I think that's where engineering leader needs to really discuss with all the stakeholders in terms of, hey, we have to get the foundation of engineering working. Like if our CI/CD is not fully automated, if we don't have loosely coupled services, if we don't have trunk-based development, how do we make those cultural changes so that we have a better foundation? So that's all about capital efficiency, right? A lot of the time, what I find is engineering leaders are the only people who understands technology in the whole group. Like for example, when you're like engineering leader is the person who understands the workings of engineering, and a lot of the time they don't advocate enough. What happens is their voice is drowned by the business stakeholders or product putting more and more requests. So a lot of the time the foundational work that you need to fix gets deprioritized in favor of delivering more features. Striking that balance is important because that's a big price to pay later on. Say, if you don't fix the foundation, I have come to Series C, D funded startups where there's no foundation. We have now doubled the engineering workforce, which is less productive. Plus, you have to deliver results for your shareholders and investors and customers. So it's a very hard position to be because now you have to do hard trade-offs.
This is a very common scenario that you have to choose between operational stability versus shipping on the feature.
Reliability is the number one feature, right?
Yeah.
So in any product. So I think that striking that balance and engineering, the voice of engineering being a strong stakeholder and really making those trade-offs early and also investing in the foundation will avoid the situation where you have to really take a step back. And like I see a lot of startups go into this when you go to Series C, They have to do a massive re-architecturing, re-platforming. You hear these words, right? Re-platforming, re-architecturing, all that happens. And then you hire a lot more people. Then all of a sudden you have to lay off a lot more people. So these things you can avoid if you really continuously invest. So the metric is, as you scale, your productivity should not decrease. Your culture should not degrade. So the smooth scaling is really around, hey, how do you keep that initial productivity, initial culture, initial mindset throughout the journey, right? And this requires a lot of foundational building. And a lot of the time especially when I come into Series C startups as a CTO, I feel this is where the biggest gap I see, that we have neglected foundational and what you call it tech debt, right? So either you pay now or pay it later. So basically, a lot of startups have to pay it later, and the price tag is pretty high when you pay it later.
Yeah. I think this has been the startup predicament that you get so busy in pushing. I remember back when I was building my startup, in a fintech, there were days where we have pushed 30 to 40 iterations in a day. And whatever feedback that we are getting, this feature didn't work for a particular customer. So we used to put on our resources into it and then, get started with it. And eventually at a point, we came to a point where we realized that, okay, we do have a feature factory. We have an app which is loaded with features, but anything can go wrong at any time.
Yeah, no, absolutely. And also a lot of the other part is, hey, how you decide what problem to solve, right? So this is also a big thing, right? So initially, when you have founder-led companies, right? So founders drive the day-to-day decision making in terms of solving. But as you scale up, now you have a mature product organization. How do you choose which problems matter? So that's where the product strategy has to come into place. Like product leaders, role of product leaders, product strategy that is informed through data-driven insights that really boil up, hey, these are the big problems that's worthwhile solving, and getting that focus narrowed down to those problems, right? But a lot of companies, what they go to is, say, everyone's favorite ask is, hey, give me a 6-month roadmap. Product team, tell me a 6-month roadmap, right? It's like asking a fortune teller, hey, tell me my life next 1 year. So instead of that, the right question to be asking is, what are the big problems that we need to solve to hit the business goals? Are these the right problems to solve? Why do we think these are the right problems to solve? How do we know whether these are the right problems to solve? And then once you boil down those problems to solve, bring these empowered product teams, three-in-a-box model to own these problems until they are solved, creates much better use of capital and biggest ROI.
Yeah.
So this is where really the startup scaling journey does not go according to plan. Is a lot of this, the biggest problem is what I call the stakeholder driven roadmap, or HIPPO opinion, the highest paid person's opinion. What goes into the roadmap, right? Right. This is the trap that people fall under. The first ask from product teams is, hey, I have a head of product, tell me the roadmap for the next 6 months. And what are the features we are going to ship, right? It's absolutely the wrong question to be asked.
I think so. There was a time when engineering used to be a support function to the business, but now looking at the things that we are building, looking at the whole ecosystem around you, that engineering is the business. It becomes a little difficult to really align the whole business and engineering. We did speak a lot about that this alignment is very crucial, but still we don't see it happening as often as we would like to see it.
Yeah, no, I think that's a great point. I think a lot of, especially when I came to Southeast Asia or in working in Asia for the last 5 years, a lot of the senior leaders that I've spoken to see engineering as like it's a back office IT. We tell them what to do and they just do it and deliver. But that's a cultural mindset. So basically, like because in the startup ecosystem in the US, right? I don't think that's how people view engineering as. Engineering is your biggest expense. It's the most expensive resource that you can have. Engineers are expensive, right? So basically how you use them matters, and it's not, you can't just throw things over the wall and get engineers to deliver, right? So it's all about, hey, how do you create the whole organization in a way that they come together, different disciplines come together to solve a problem, right? So a problem that's big enough to be solved, that has a big impact on the consumer and really moves the bottom line for the company, requires a lot of people to come together to collaborate in solving that problem. So getting all these players, especially the three players, that is the product managers, designers, and your tech leads, from the beginning of product discovery through to the end, and spending the entire life cycle together to really crack this problem and solve it, will really, that's the change we need to have in the mindset. So engineering is a equal or important stakeholder of that whole cross-functional empowered team that works very closely with product and design to really focus on the problem from discovery to delivery of the outcome.
So when the first big shift happened from an individual contributor to the, let's say, the project manager or the team lead, and then further, what is that one thing you wish you knew that could have made you a better leader in the first place? And during that crucial phase of transition from IC to a management person.
No, I think the biggest thing is, when I was first time CTO way back in early 2000s, right? I was horrible. Like when I look at myself, like now and then, like I completely didn't know what I was doing. And it was a lot of trial and error. There was no good support system to tell like, hey, this is how you manage people. So the most difficult part is like being IC to having a few people under you is a first set of transition. So then you become the first time manager. It's important to have good mentors to tell you, hey, how do you manage people for the first time? And how do you really empower people to bring their best to work? How do you create a culture where everyone thrives and achieves their full potential? And the next biggest hurdle for leaders is managing managers or managing other leaders and driving outcomes, right? So that means you're 2 degrees separate from the actual engineers who are doing the work. So that is very hard skill to master. Then you have to understand, hey, what are the right questions to be asking? How do you prioritize? How do you keep the focus? Then you have to know more about the business to give direction. Because a lot of the time, as a leader, your job is to really understand the business, understand the strategy, and boil it down to choices that give clarity to your teams and the next level so that they can go execute. Without that clarity, what happens is, if that clarity is not there, then it's going to be chaos and uncertainty, right? That's where people start burning out, people get stressed, why people get stressed? People get stressed because of uncertainty, right? Uncertainty. So as leaders, you have to reduce uncertainty in your organization, give them focus, give them clarity, so that they know for the next 3 to 6 months what they need to deliver on outcomes. So these were things that I learned the hard way, like trial and error. I was, as I said, like I was a horrible manager. Teams quit on me, and I learned it truly the hard way in terms of really honing the skills. And I was lucky also at some part of my career to have great mentors along the way. And still, after 2 decades, these mentors are still, I talk to them. And so that was a big part. So that mentorship, transitioning from IC to engineering leader, and holding a C-suite position like CTO, and really your job, what is expected out of your job changes at every level, and really understanding here what is the level of what is my expectation, and am I performing to my expectation? If I am to perform to my expectation, then what sort of team I need to have, what sort of people I need to hire, because hiring becomes your number one priority. If you hire the wrong people, you're dead in the water, right? So hiring becomes the number one priority. Then, and what are then the direction and clarity you give them, and empowerment you give them, the culture you want to have and create is going to be very important, right? Otherwise, if you are the one who's really the brain and everyone else is your arms and legs, like there's no life, right? You won't have time for vacation. You won't have time to recharge. You'll be running on empty. You'll be burning out, and people will churn. So basically, how do you really create that organization? So these are the harder things to learn. Like there's so now I think there are people who have written books about it. And when I started, like it was very uh, trial and error kind of transition. And also, luckily, I had good mentors to help me through that process to reduce the rate of failures that I was having. But still, it was a hard journey. So if I look back, I think if I had known what I had known, if I can give back to young CTOs or engineers who are coming through these podcasts or writing that I do, I write a lot. So I have a blog called Go Nail It, Scale It. So I try to write these down so that the next generation of leaders can learn from this quickly and really apply that and see what works, what doesn't work, and don't have to go through the same hardships.
So, how do you see? We did speak about engineers losing their leverage because now even AI can code now. I mean, your ability to code is no longer a leverage that you hold. So with the whole AI coming into the picture and the whole engineering process becoming so complex with business coming into it and so many other moving parts, how is AI helping engineering leadership? How do you see the role of AI in making better leaders or helping them run better engineering?
Yeah, I think for the initial part, right? So the basic things like how do you, AI can be used to maximize productivity, especially your co-pilot or your AI assistant in IntelliJ, and also having AI integrated to your CI/CD pipeline to do code reviews, right? And tell you where the high risk areas are in your platform and in your coding so that you can automate those better. So AI can be used to really enhance productivity, and also for average engineers, using AI can really get them skills that they like. You don't have to go to Stack Overflow, Google to figure out the answers. You can ask in the context the question where you can get the answers. So I see a big, huge productivity improvement. So that means startups can leverage AI assistants or agents to do more with less people, right? And as AI gets cheaper and cheaper and improves, AI will take on some of these tasks of like AI ops, like how do you improve observability, fault detection, error detection much more earlier than humans do, and really the alerting, monitoring, observability, reliability aspects of production can be really improved. So there's tremendous amount of applicability in engineering for AI to improve the productivity of existing engineers, especially now you can have an average engineer with AI be a super high productive engineer. But really the differentiator is not the ability to code. Those are all going to get automated out, and I believe AI will play a big role in that. But for engineers now, the focus is, hey, how do we solve complex problems? How do you get to know the business? It's not about the language or the technology or the certificate that you have. It's really about, hey, applying all that to solve complex business problems and drive value for your customers, your shareholders, and your business, right?
So what are some tools or applications? You spoke about observability. And is there any recommended tech stack that you are using or any tools that you're using?
You can have a completely I've used the Linux tech stack, like complete open source tech stack, or a commercial, like I've used New Relic and Datadog, those kind of tech stacks, and Grafana. It's all about really boiling down to what are those reliability metrics that you want to track, right? So basically, I think really understanding from the business, say what are my SLAs, what are my what should be my SLOs, and what are my SLIs, and do we have ways to track them, monitor them, and even simply if you pump those logs out to Grafana and have alerts and a basic way that you can really start doing some threshold analysis and stuff like that would work. So you don't have to get fancy like a lot of these off-the-shelf products, make it easier, but also simply understanding, hey, what are the SLAs that I need to make sure that for my business and for my customers, most important, what are those, how does those SLAs translate into objectives that my teams need to now adhere to, and how do you measure them? A lot of the time, the observability piece, engineers, oh, it's not my problem. My job is to get to production, and it's somebody else's problem,
Yes.
right? So that mindset is not the right mindset, because the number one feature is reliability. It's the number
Yeah.
one feature in your product, right? So you treat it as that.
I think I'm going back with two t-shirt slogans today. One is startup is an intellectual sport, and the number one feature is reliability. I think this is going to be like, I mean, this is too right on the face. It's something so simple that's it's always
Yes.
been around us, but it often gets overlooked with the whole pressure. It was wonderful having you. And I do feel that we have a lot more to talk about. I think we just couldn't really fit this in this small time frame. But I would want to sit once again with you, maybe next time in person, and have a good chat about this.
Okay, no problem, Manchu. Thanks a lot for having me. It was a pleasure.
That's all for today on the Engineering Success Podcast. Stay tuned for more.